All right, here's a little video for 8.3, heating curves. The question for this lesson is, what does the heating curve for water look like? And, you know, whenever students are first asked this question, they normally draw out something like this, where, you know, I tell them that the heating curve is something where, you know, we have time/heat added on the x-axis, and so you know, as you go from left to right, you're going to be adding heat, and then on the y-axis we have the temperature, and so as you go up, you know, temperature is going to be increasing, and what students think is probably it looks something like this, right? Where as we add more heat, temperature is increasing. Or, you know, another one that they draw is they think it looks something like this. Sorry. Right, where it's like, okay, as you add heat, the temperature will increase, but it'll actually increase at an increasing rate. Basically, it'll become, the temperature will increase even faster over time. Or another one that they draw is they think it's going to increase, but then over time, actually, the amount it's going to increase is going to slow down, and so it's actually going to level off over time. And so they draw one of these three, none of which are unfortunately correct. That's okay, right? That's why we're here. What it should actually look like, the correct heating curve for water, looks something like this, where we have time/heat added on the x-axis, and we have temperature on the y-axis, temperature in degrees Celsius. And what it looks like is it is linear at first. As you add heat, you are going to increase temperature, but then what happens is actually you have a leveling off until you reach a certain point, and then it actually increases again until it levels off, and then it increases again. And so this is actually what the heating curve for water looks like. And what's happening here is there's a couple different points that you, points of note. So we can think of it as A, B, C, D, E, and then F. Where basically at A, what we have at A is we just have, it's the lowest temperature, and so that's a solid. It's solid, it's ice. What happens at B is we start to go through a phase change. That phase change, right, when we go from a solid to a liquid, of course, right, we call that melting, right? And so what's happening here, starting at B all the way until C, where at C we finally become a liquid, is melting is occurring here. Of course, that's if we're going up. If we're going down, right, we're going to call that freezing, right? And so here, at this point, at the flat parts, there is a phase change. And then at C, we're going to then, you know, take that liquid and we're going to increase in temperature. As we add heat, temperature is going to increase up until we get to D, which at D, we're going from a liquid now to a gas. And so here, we call that, of course, vaporization, where we go from a liquid to a gas. And so we can put that here, all the way until we get to E, when we're fully a gas. And then F is still actually gas. So, but yeah, so this is what's happening here. Now, of course, if we go in the reverse process, if you go from a gas to liquid, we call that condensation, right? And so, yeah, this is what's happening in a heating curve. And of course, we know that this melting is happening at 0 degrees Celsius, right? And this vaporization is happening at 100 degrees Celsius. But yeah, basically these flat parts, these represent phase changes, right? These are phase changes. So yeah, flat is a phase change. Now, you know, for regular chemistry, we'll just kind of keep it here. We can identify these. For AS, I did have you guys do this worksheet, where actually what we can do is we can calculate the amount of energy at each of these steps. And so all of these are relatively easy problems. What I'm really interested, though, is in 8 and 9, where basically, if we're going from A to B here, what we can do is we can actually calculate the amount of energy that takes. So here, point on the graph, A to B. The formula you're going to use is you're going to use just Q is equal to MC delta T. And here it says we have 2 grams of H2O, and so mass is 2 grams. Sorry, mass is 2 grams. C for water is 4.184, right, as always, kilogram degrees Celsius. And then delta T, if you're going from, it says here negative 20 to 0, right? That's a positive 20 degrees Celsius increase. Positive 20 degrees Celsius increase. And so you're going to do 2 times 184 times 20, and you'll get 17.36. We only have 1 sig fig here, so technically it should be 200, but let's just make it 170. And so here, this should be, it's a little bit cramped, but 170 joules. All right, so that's the answer for this one. Basically, to do this, to go from A to B, is going to take 170 joules are needed. And we can do that via this equation, which we plugged in the stuff here. So yeah, 170 joules are needed to take 2 grams of solid water, ice, and turn it into, to get it to the point where it's going to start to melt. B to C, though, from B to C, when it's flat, we have to use actually a different equation. We have to use, we're going to have to use this equation. Q is equal to M times delta H of fusion. And the reason we're going to have to use that equation is because if you think about it, here, there is no delta T, right? There is no change in temperature. Delta T is equal to 0. And so if delta T is equal to 0, if we were to plug it into this equation, we would get a 0 here, which would cause Q to be equal to 0 because, you know, even if these things are huge, whatever this is times 0 is going to be equal to 0, right? And so, yeah, we can't put delta T is equal to 0 because that wouldn't make any sense. It would say that then, therefore, the heat that we're adding here is 0, but we're not, right? We are adding heat. We are adding heat as time goes on. And so that wouldn't make any sense. So we're going to use this equation instead where we don't have delta T. We just have M times delta H of fusion. Q is equal to M times delta H of fusion. And I'm just going to put delta H of F. Fusion is another word for melting. Chemists always have their own big words for everything. And so Q is equal to M times delta H of fusion. And so what you would do is you would put in M, which is 2 grams, right, the mass of our water, and then you would multiply that by whatever the delta H of fusion is. I think the delta H of fusion here is going to be, and I wish this were should have given it to us, but the delta H of fusion I think is something like negative 336, or sorry, positive 336, something like that. Now, whatever I give you, right, kilojoules per gram, whatever I give you, right, just plug it into here. So you'll have to be given that on a test. But yeah, just plug it in there and you'll be able to calculate whatever the amount of heat is. Let's say it is 336. Don't quote me on that, please. But if it is 336, right, you just do 2 times 336. And that'll be equal to 672 kilojoules here. And so that's how you would do that problem. Now, similarly, Q is equal to M times delta H of vaporization, right? That's what we're going to use for when we're going from D to E. And so here we're going to use Q is equal to M times delta H of vaporization. And then, of course, the equation that we're using here is we're going to be using Q is equal to MC delta T, right? That's from C to D. C to D, I'm using that. And then E to F, this portion here. Again, we're just going to be using this. The standard, because, you know, delta T is greater than 0, and so our equation will actually make sense. And so, yeah, so that's how you do these problems. These are the hard ones, but yeah, pretty relatively simple still. It's just plug and chug. Here too, what they're doing is they're just giving you different grams. Right now they're saying 5 grams instead of 2, 5 grams. Again here, you would have to use Q is equal to M times delta H of vaporization here, as well as delta H of vaporization here, and similarly here, you're just going to have to plug it in with the right formula. Again, it's just plug and chug. You have to identify what formula to use, and then plug in the correct variables, which, yeah, you know, I could make like a 1-hour video going over all of these, but hopefully that gives you guys at least some to base it off of and the general direction for how to do these ones. So hope that helped. Let me know if you have any questions on the other ones. I'm happy to help you one-on-one. But yeah, hope this goes well for you guys.